This is the P2 Block 1 webinar to support the delivery of the Glasgow City Council Numeracy and Mathematics Progression Framework. If you are part of Glasgow City Council's primary practitioners, please join the Microsoft team available with the team code on this slide. Here you will find all documents relating to the delivery of numeracy and mathematics for primary schools, and also collaboration folders where you can find resources shared by your colleagues. As we move from Glasgow Counts to the new progression framework, there are certain things that are remaining the same and some things that are new. What's the same is that we have an annual overview which displays the content to be covered by each primary stage. Research hasn't changed, so the concrete, pictorial and abstract approach to introducing new concepts is still what we're looking for. Problem solving should still be at the heart of all your teaching, providing real-life scenarios and providing a rationale for learning the concepts you're teaching. We are expecting a high degree of fluency with mental strategies by the time our pupils reach primary 7. So all of that work around various calculation strategies and the use of number talks is still very much valid. And any resources that you have been using to date, textbooks, worksheets, etc., will all still be valid and useful in this new progression framework. So what's new? Really is the technical framework of our teaching that is different. Instead of a full annual overview being the only guide, you have 6 blocks of teaching planned for, each block spanning a period of around 6 weeks. At the end of each of these blocks, there will be end of block assessments available for you to use to assess the learning of that block of teaching. And to this end, you will also find populated medium-term planners for each block with suggested learning intentions and suggested support and challenge guidance also. What is more explicit in this set of progression planners than in our former set is you will find a direction in terms of when to introduce different strategies for your teaching. And there is also a number fact knowledge progression, which will say, for example, when certain times tables should be introduced and become secure by. Here's a screenshot of part of one of the annual overviews. The yellow highlighted section at the top is showing you the year group for which this annual overview is relating to. The green section's highlighting the titles for each block, each of which gives an indication of the months of the school calendar that this block should be taught in. Down the left-hand side, highlighted in red, you'll find the organisers, or different areas of maths that are going to be covered. And then the blocks run vertically. So the area in blue, for example, is showing you the teaching points for block 2. Each block then has an overview planning page, like the one shown. The core teaching points for this block sit in the middle column there, with the heading highlighted in yellow. To the left of that, the column to the left is headed support and gives you the teaching points that come before in the progression for each area. And on the right-hand side, you have a column for challenge, which will tell you teaching points to move the learning on for those who are ready for it. Also on this planning page, you will find example learning intentions, which give a suggestion of how to cover that learning over the course of 6 weeks. We're providing this to indicate how quickly we need to move on from concept to concept, because with the new 6-block framework, we'll be revisiting concepts every 6 weeks So certainly all the core number topics like place value and addition and subtraction, multiplication and division and fractions all have teaching points in every single block. And so what that means is during the course of one block, you may only do 1 or 2 lessons on each of those things, but teaching a very small part of the progression of addition, for example, knowing that in 6 weeks' time or before, you'll be coming back to that addition and moving the learning on slightly. The learning intentions are written with some core number topics and some beyond number topics featuring in each week of that block. That's based on current trends of planning, whereby teachers in the primary sector tend to run core number and some beyond number topics alongside each other. We know also that many job share partnerships divide the planning and delivery of teaching in this way. So that was to reflect current practice. The sample learning intentions are written in a child-friendly manner. They're very short and to the point. And you'll notice that they are generalized in terms of the main concept of the lesson. The specifics of the learning would appear in your success criteria and therefore could be differentiated. But for example, if we look at addition, simply we would have a learning intention stating we are learning to add, which the whole class could be working towards, even if they are doing so in quite different ways. I'm going to take you through the teaching points of this block now and reference the sorts of resources and pedagogy you'll find useful in delivering these points. While I'm dealing with each organiser in turn and working down the block, as we've mentioned with the learning intentions, you won't be teaching addition without talking about and using counting skills and place value. So be mindful that the skills will cross over into multiple lessons and not simply be delivered one after the other. So our first organiser is number system and number fact recall. And as you can see in P2, we're dealing with extending the range of numbers that the pupils will be learning to deal with up to 100. So counting, ordering, creating representations of numbers to 100, partitioning those numbers into tens and units, putting these numbers on a number line, and then we're introducing the concept of estimation at this stage. In terms of their number fact recall, we're interested in them recalling doubles up to 10 and the associated halves that go with those, their number bonds to 20, and starting to recall the 10 times table. So, looking at the first couple of teaching points in this organiser, we're extending our confidence with the number system to numbers to 100. By the end of P1, the new framework will expect an on-track P1 child to be working with numbers up to about 30. But as always, some will start P2 not there yet, and some may already be confident beyond 30. These two teaching points will require lots of practice to build a secure conceptual understanding of 2-digit numbers. And to do that, we're using concrete materials or their digital equivalents, as shown in the screenshots there, in order to model that. So exercises like the little train there, which is asking pupils to order 2-digit numbers, or the Top Marks Caterpillar game, which is very similar. They're great and very valid, but for the pupils to be able to confidently do that, we need to do lots of counting routines, counting backwards and forwards with numbers up to 100, probably not always starting at 1, but perhaps counting from 27. Especially practicing those bridges across the decades, so 27, 28, 29, 30, and understanding which decades come next, which many pupils do find tricky initially. Pupils will also be more able to order the numbers if they have a secure understanding of that first digit being the tens and the second being ones. As adults, if we were ordering, we'd be looking at the largest value digits first, and then if we find multiple numbers with the same number of tens, we would be looking then to the ones. So in that example with the train, we've got two numbers in the 40s. So in order to decide which one comes first, we have to look beyond the 4 tens and look at the ones. So we need to model that very clearly with them. Other visualizations that you'll have in your numeracy-rich classroom environment would be things like number lines or tracks, any board games with like snakes and ladders, or anything with a basic number track to follow as they roll the dice, and 100 squares, all serving to raise awareness of the number system being based on tens and having a familiar pattern between the decades. We're introducing at P1 this vocabulary of partitioning and modelling the regular partitioning of two-digit numbers, either with Dean's materials or place value counters, and that's crucial for building understanding for calculations later. Mental math strategies that we teach later on, and our column methods for addition, subtraction and multiplication in the upper school are underpinned by that regular partitioning. The columns are based on tens and units and those values. So concrete materials that the pupils can touch and manipulate are what's age and stage appropriate for P2, but the online tools that you see screenshots of on this slide are really good for modelling on the smartboard. Once pupils have used the concrete versions and they understand what those digital representations, what those digital images represent, they can also use games like the one at the bottom right there on the iPads to reinforce their learning. And those of you that have already dipped into Magma Maths will know that manipulatives are available as tools on that platform for pupils to use when they're completing assessments. So number system teaching point C is asking pupils to place numbers to 100 on a number line where the increments are marked. And that's an important distinction because as we move into P3, we'll look at number lines where perhaps we're asking them to estimate the position of numbers between two increments. But at P2, this is the first time we're asking them to complete missing parts of a number line for us. Number lines may have been encountered in P1, but again, we're extending that range of numbers and we're applying our counting skills to this visual representation of that counting sequence. So we're looking at number lines where every increment's marked and the increments are only going up in ones. So labeling missing numbers and effectively reinforcing our counting, our ordering, numbers before, numbers after, and so on. When designing your activities to have your pupils engage with the number line, do be mindful of motor skills at their stage and their early writing development. It might not be reasonable to expect a pupil to label accurately if the printed number line that they're engaging with is very small or only offers a small space for them to write in, depending on how develop their fine motor skills are at that point. So you may want to consider larger models, maybe number cards to place on the line in a small group setting facilitated by an adult. So you can use your professional judgment in terms of that. Teaching point D, estimate the number of the same object and then different objects in a row and count them to check. So estimation will move on as we go through P2 and P3 to being objects in random arrangements and different types of objects in random arrangements. But at this point, we're trying to introduce the vocabulary of estimating. We're going to explain that it's a good guess. And we're moving on from them counting objects in rows, being able to count effectively, to actually using their supervising skills to give a good guess of the number. We explain that when we estimate, we do not count, but of course pupils love to get it right. So you may want to consider quick flash type activities whereby they see the image briefly and not allowing them enough time to count before they give their estimate. Any sequences using mini whiteboards or similar to record their estimate before they then count to check are useful. You may want to do that in pairs and one suggestion is there at the bottom of the slide. So last slide here in terms of number system and fact recall. The skills that we have in these teaching points actually reappear in every block of P2. So we're going to be working on these skills and won't become completely secure with them by the end of block 1. But by working on the recall of doubles, we're going to lay the foundation for the 2 times table, which we're going to introduce in block 2. At this age and stage, pupils need multiple visual representations of those doubles to enable their brain to become secure with the concept. So working on doubles to 10 means we can offer visualizations with things like dominoes as shown there, or dice would work as well. 2 dice turned to the same number representation on each one. Pairwise layouts on tens frames are very useful, so as shown there. You may be familiar with the fact that there are 2 types of layouts on a tens frame. So these ones that you can see on the slide are pairwise because as we add an extra dot, we're creating a pair each time. The other type of layout for tens frames is where we add a dot along the top row first, so that the representation of 5 would be 1 row complete and 1 row empty, and then we would fill the second row. So pairwise are useful for things like doubles and multiplying by 2, but the 5-wise, we call the other version, the 5-wise tens frames actually support supertizing because in terms of our brain's capacity to supertize, we can see up to 5 items. So when we're supertizing with a tens frame, we're actually looking at 5 plus something and breaking down the number in that way, partitioning the single digits. Going back to this as a representation of doubles, finger patterns are also really helpful for doubles up to 10, so double 2 by showing 2 fingers on each hand, for example. By the end of the P1 progression, number bonds to 10 should hopefully be secure, so we are then going to work on those and extend that to number bonds to 20. So we can model these with 2 tens frames or with Dean's materials, and we can explicitly model that relationship between information that they already know, like 9 plus 1 makes 10, with a new related pattern in terms of, instead of 9 plus 1, we're talking about 19 plus 1 making 20. Laying the foundations that the 1s total 10, and then the other 10 is sitting in the 10s column. And that's the foundation for them finding friendly numbers on open number lines later on, or finding change. But the work done now will free up that working memory for them, rather than them having to work everything out on their fingers every time they try to do an example. So if they're working with an open number line, jumping up to the next 10, if they have got their number bonds to 10, they know that to get to 20 from 13 is 7 without counting up and then forgetting what they were actually attempting to do beyond that jump to the friendly number. As I explained in the introduction, these new progression planners explicitly direct the teaching of times tables at different stages, and that's because we want to document the critical path of an on-track learner from P1 to P7, and that on-track learner should then be on track to achieve well at Nat 5 and beyond. So whilst conceptual understanding is and will always be the most important thing, and some pupils will find learning times tables difficult, we know that most will be able to recall tables to 10 times 10 with practice. And we have the great benefit nowadays of individualized tools and many digital tools, so that pupils can practice without that shame or fear of whole class pupil versus pupil testing. So please still avoid games like that where one pupil is pitted against another and it's all based on speed of recall. Things like chanting tables are fine, frequent recall practice, and as I say, these individual recall games. And ultimately, a P7 who is secure with the times tables to 10 times 10 will be much better able to attempt more complex problems, and later they'll feel less under pressure in timed assessments because they'll be more efficient and their working memory is freed up to think about all the different stages of the problem that they're trying to attempt, rather than worrying about what 8 times 7 is. So in P2, we're looking for pupils to become familiar and recall as much as possible of the 10 times table and the 2 times table. In this block, we introduce the tens only. Pupils will become really familiar with this pattern really quickly. So moving on to our next organiser, we've got 2 teaching points under addition and subtraction. In P1, we looked at adding and subtracting numbers within 10. So again, as we're starting P2, we're extending that skill to a wider range of numbers. So we're looking at adding and subtracting with numbers up to 20. First skill then, in P1, and as pupils enter P2, it's very likely that they will struggle to count on from the first number to add. So in this addition calculation, we'll model and expect them to count on to 12, to count out 12, like that, and then count out 7, and then be asking them to find the total. So having counted these 2 groups, many at this stage will still recount from 1 to find the total. We need to explicitly model by touching the first group and saying, so we have 12 there because we've already counted those. So 12, touching that group again, 13, 14, 15, 16, 17, 18, 19, indicating each of those additional items to reach 19. When a pupil does it and starts again at 1 and gets the answer right, we of course celebrate that, say you're right, it is 19, but also remodel our counting on method so that over time they will get used to holding that first number in their heads and counting on from 12. We can do the same thing with tens frames. So laying out our 12, counting out 7 counters, and then popping them in the second tens frame with the 12, with the 2 of the 12. And depending on how familiar the pupils become with those 10 frames layouts, they might then not need to count to tell you that the total is 19. They might be able to visually tell you that that is 19. And effective questioning that we can use around that might be, well, how did you know? And potentially we'll have that number sense rich chat of, well, I know that because there's 1 missing, so it must be 19, or because 19 add 1 is 20. And if it was full, there'd be 20, and so on. Pupils might be able to move on eventually to holding that first number in their head and making the second number on their fingers to count on, but they're much more likely to be able to do that after they've had lots of concrete examples and practice with Deans or tens frames in this way. So exactly the same with subtraction here. And so I've got the inverse calculation to the one we've just seen to make it even clearer. One common misconception with subtraction is to want to make both numbers as they have done in addition. So counting out 19 and then wanting to count out 7 and lay it out as well. So what is helpful to unpick that misconception with them is to base your calculations in worded scenarios. So actually talking through, Ava had 19 cakes and she ate 7, and potentially miming eating the counters or whatever represented the cakes, talking about how many were left. We're helping them to understand that subtraction is a takeaway, a removal. So as we talk that scenario through then, we count 7 of the original group and we must take them away And particularly helpful at this age and stage is to remove them completely from view to avoid any confusion about what the answer is. So then when we've removed those 7, how many do we have left? And they can very clearly see then that they have 12 remaining. Again, pupils will eventually be able to move on and start with 19 in their heads and use their fingers to count back, but only after lots of concrete practice to embed that concept. So again, we could model this in the same way with tens frames, starting with our 19 and then counting away 7 of those, removing them completely to model that we have 12 remaining. Okay, moving on to multiplication and division, we have only 2 teaching points, and I have in fact already mentioned them in number system and fact recall earlier. In this way, the blocks have been designed so that there are natural links across the teaching points. So you should hopefully find that when you're teaching these teaching points across 6 weeks, they lend themselves to repetition and revisiting by linking really well into each other. In this block, we're looking at multiples of 10 and introducing the notation of times, so introducing that X symbol of times. So there are lots of lovely ways to model that idea of repeated addition of the 10 times table. Lots of our specific mathematical concrete materials that represent the tens. So tens in Numicon laid out there, Dean's tens. We could be counting up in full tens frames, so counting 10, 20, 30 in that way. Could be using 10p pieces. 10 fingers per person and everybody flashing up their 10 fingers as we count up through the tens. So all of those visualizations will help lay the foundations of repeated addition. And even with tens being a very intuitive pattern, it's helpful to see how that repeated addition works, and that will lay the foundations for all our other times tables too. You can also use any number of online songs and chants to practice, point out where the pattern of the tens is on the 100 square and so on, as we always have. And that focus on the decades and the pattern of the tens will also help with that core counting skill of bridging those decades, as we mentioned before, so avoiding children being quite happily counting up through the 30s, getting to 38, 39, and then telling you the next number is 20, for example, which we hear often. If we teach the commutative law early as well, by exposing pupils to both 10 times something as well as something times 10, we give them a really helpful strategy for later on. So when they get further up the school, they may struggle to become fluent with the less pattern-based times tables like the 6s and the 7s, but if they already know the 10 times table, the 2s, the 5s, potentially their 3s and their 4s, they actually know many of those parts of the 6 and 7 times table, as long as they are very confident with that commutative law and can spot the part of the calculation that they're most comfortable with. So we want to introduce that early on and make them aware that 10 times 3 is just the same as 3 times 10. The last of the core number organizers is fractions, decimals, and percentages. Obviously, we're just talking about fractions in first level and primary 2. And as I said, there are teaching points around fractions in every block. The spiral approach of revisiting them every block ensures that those core number topics are revisited and built on through the blocks. And what it means is you won't spend 2 weeks doing fractions. You might spend 2 or 3 lessons each block, enabling those distinct skills and concepts to land and be processed and then revisited and built upon. It means we won't have any year group that hasn't been exposed to vocabulary and examples of fractions for several terms before we inherit them. So for fractions in this block, we've got 3 teaching points. Being able to shade half of a symmetrical shape, being able to identify a shape that's been equally halved, and being familiar with and being able to write a half in words and with the correct fraction notation. So the first one is a straightforward skill. The idea of a half is a familiar one, but pupils might not have seen the mathematical notation, or if they have, not be familiar with the idea of a half being 1 out of 2, or being talked about in that way, so 1 piece out of 2. And we can introduce that to help with stimuli like letter D on that, letter E, is it? No, letter D on that left-hand exercise. Most pupils will see that shading one part of that shape that's been split into 4 isn't half. They'll be able to recognise that because they're very familiar with what half of something should look like, that it's fair, that it's even. But we should model that we would be shading in 2 parts because it's 1 part out of every 2 that we have. So it's 1 out of 2 parts. In P1, the teaching point before this one on the progression, before B on the progression, is being aware that halves must be equal in size. So here we are applying that concept, is it a half, with lots of different examples, but these are abstract examples, whereas in primary 1 we might have been looking at an apple that's been cut in half, well or not well. So practice using the notation as well and learning to write the word half, which is a tricky spelling, is time well spent, because we'll come on teaching points in time in block 2, but obviously use your professional judgment again around motor skills about whether this pupil is still mark making and not yet moved on to early writing skills. No writing related teaching point for maths actually appears in the mathematics benchmarks at first level because of that consideration. So moving on from those core number topics, as in every block, we have 2 beyond number topics in block 1 to cover. We have teaching points around shape and space, which appears in block 1 here and also again in block 4. And we have teaching points around information handling, which appears in 4 out of our 6 P2 blocks. So just to underline, the core number topics we've discussed so far will appear in every teaching block and are built on in a spiral way to ensure that retrieval practice is really built into our planning and we're revisiting all of those concepts regularly. Teaching points within core number and beyond number have been matched as far as possible to encourage natural links to be made in your teaching. We've got a good example here with C, which is asking pupils to fold shapes to find lines of symmetry, which links really nicely to those halving fraction skills we've just looked at, and we can talk about them when we're looking at halves related to doubles in our core number knowledge too. So in terms of teaching point A here, naming regular 2D shapes up to 6 sides. In P1, we have the equivalent was looking at common shapes, which included a rectangle. But in P2, we want to introduce the mathematical vocabulary of regular shapes. Now, thanks to McDonald's and the like, regular is often understood by pupils as meaning normal or common, but we want to be precise with this from the early stages and help them understand that there's a family of regular shapes, a group of regular shapes, and their criteria is that all of their sides should be equal in length and all their angles are equal. So rectangle is not part of that family. It is an interesting shape, and it's a special quadrilateral, part of a whole range of other special quadrilaterals, which we'll explore much later. But in fact, rectangles are not a regular shape, so that's an important distinction to make. Regular shapes also have the same numbers of lines of symmetry as they do sides and corners. And they'll be wondering about a circle and thinking, well, it's got one side actually, because that side's curved, mathematically it has an infinite number of sides and lines of symmetry, which is a little bit beyond P2, but they might ask you, so it's worth having the answer ready. And so linking to that, this gives us nice possibilities for lots of investigative activities on our last teaching point. So if the shape is regular, I should be able to fold it in as many ways as it has sides or corners. And in terms of the activities around this, obviously it is asking for pupils to fold, but again, be mindful of motor skills development that could be a barrier for this learning. So you could adapt that by a pupil lying a ruler or a pencil or using a mirror to show you where they would like to fold the paper if motor skills don't allow for that. And finally, in this block, we have one teaching point within information, data and uncertainty. So recognizing that these are the first 6 weeks of term, the planner suggests that in this block, we engage with our environmental displays to lay the foundations for more mathematical data work later on in later blocks. So we're asking the pupils to answer questions by reading information from a range of displays that you have in the classroom. So how many children are here today? If you've got some sort of visual registration, what does the visual timetable tell us we'll be doing after lunch or after break time? And so there's lots of possibilities, and you can consider the questioning potential of any displays you might want to create as you welcome your new class at the beginning of the year. This teaching point has the double bonus of pupils being engaged in the maths of your displays because the data is relevant to them, as well as becoming more engaged with your classroom management systems in general. So if we ask questions about the house points as part of our teaching input, then hopefully children will be more likely to ask themselves those questions in subsequent days and generally engage with those numerical relevant data collections that are around them. Okay, so that's us got to the end of the walkthrough of all the teaching points for this block. As we have communicated, the implementation of these new progression planners is going to run over 2 sessions, 2 academic years. So we are very welcoming to any feedback you would like to leave us. So please do that by using the QR code here. We will be communicating more information around those end of block assessments early on in the session 2026-27, and there are going to be webinars of this type to walk through each block for each primary stage. Everything, all the recordings of the webinars, all of the documents will be available on the Microsoft team, as I mentioned at the beginning, so please do join that. And then just at the end of this presentation, you've got a couple of slides with useful resources on being links to anything that there's been a screenshot of earlier in the presentation. And then the very last slide, and this is available on the team as a PDF as well. These QR codes are scannable for use with the school iPads so that pupils can be taken directly to a digital manipulative, so that if you find yourself with not enough Dean's materials or you would like certain children to be using a digital version of that, they can easily navigate and go straight to those pages without having to go through the menus and etc. on MathSpot. So hopefully that is useful to you. Thank you very much for listening, and do get in touch if you have any questions or queries in terms of delivering P2 Block 1 next year. Thanks very much.